Well, my name is Jim McDonald. I'm going to follow up the conversation today, move the conversation towards more grazing work. Both Dr. Aaron Stocker and I will be discussing grazing. I'm going to be talking about it from the perspective of the growing calf, a weaned calf that you would take out in the fall. Aaron will be talking about it more from the perspective of cow-calf, grazing the cow. I'm also going to open the conversation a little bit on subsequent crop yield. That's obviously an important part of the whole residue utilization. So I'm going to introduce that topic, and Dr. Wortman will follow that up a little bit later on. This has been a common theme throughout the discussions that you've heard today. Dr. Brooks talked about it. Dr. Residue talked about hay price. Forage has been increasing not only because of the drought. I guess that's what I would add to the conversation. So this is a UNL publication called Cornhusker Economics that shows the average Nebraska pasture price in dollars per cow-calf pair. Here we go from 1990 to current times. And so as you go up to where we're at today, you see a steeper increase in the price of pasture. But don't misunderstand, the cost of pasture has been increasing linearly for a long, long time now. What we don't know is if we're at a new slope or once we get past this drought, if we'll come back down to trend line increases in pasture price. But we are unanimous, I believe, in that forage prices have increased. Probably most people are familiar with this chart. This shows U.S. corn production from 1950 to current times. Everybody talks about trend line yield, and certainly corn yield has increased. Everybody recognizes that. This is millions of acres harvested. So this is bushels per acre, and this is millions of acres harvested in the blue line, which remains relatively flat, except for the last couple of years. Since the 2006 era, we've seen a pretty substantial increase in the number of corn acres. So Dr. Klopfenstein talked about on a dry matter basis, for every pound of grain that's harvested, of course we measure that in bushels, but for every dry pound of grain that's harvested, there's 80% in. So what I've taken, and I've just taken that yield and multiplied it by the harvested acres and multiplied it by 80% to get to the millions of tons of available 1950. And you can see that that's also, there's a trend line there, but that has increased substantially. And residues is not a new concept. Cattle grazing residue in Nebraska long, long before I was alive. But what has changed is the amount of residue that's available, the price of the available to us. I suspect that that's why most of the people who are participating in this event are listening right now. So the challenge, corn price, of course, have increased. That increase in corn price has affected forage in two ways. One, we've seen the conversion of pasture to corn, and then because of the decline in the acres, either in pasture that are available to us or in farm acres that are utilized to produce forage, alfalfa, for example, have declined and then put more towards the corn production. The supply and price of forages have increased over time. So with every challenge, we hope to find an opportunity, and so we think that increasingly the opportunity is in more intense utilization of the residue. In fact, that's the only forage resource that I can think of that's increasing. We talked about loss, more expensive hay, loss of acres from hay production, loss of pasture. This is really the only forage resource that's increasing, at least that I can think of. So if we're going to talk about grazing a lightweight calf or a growing calf on residue, we need to think about the nutrient requirements of that calf. Residue is going to be relatively low in crude protein, and so the number one thing that we need to supply is a protein source because because it's low in protein and because it's a relatively low quality forage, Dr. Rasby talked about the advantage of using ammonia to increase palatability, increase digestibility, but there's also nitrogen that remains and continue to cellulose. Same nitrogen requires for a calf grazing corn residue, but we haven't provided it. So you need two forms of nitrogen. You need a form that's available in the rumen, so rumen degradable protein, or a DIP as we've often called it. And that calf has an amino acid requirement at the level of the small intestine. Crude protein requirements of a growing calf recognize that a degradable intake protein or a protein source is available in the rumen as a protein source. Of course, we've talked a lot about byproducts today, and so how you provide that protein, there's historically been a lot of work done with different supplement forms, but I'm going to focus on distillers grains simply because it's the most common form and the most abundant form of supplement that we've got in Nebraska. So if you're going to talk about distillers grains, you need to think about calcium and phosphorus. It's already been mentioned once today that providing distillers grains brings phosphorus in with it, and that's probably not a bad thing from a growing calf perspective. But you may also want to consider adding some limestone to that supplement to keep the calcium to phosphorus ratio in balance. And then any additional energy we can provide on top of that should then improve average daily gain. So this is a summary of 3 experiments that I've put together looking at distillers grain supplementation on low quality forages. 2 of those are distinct to corn residue. So this is some data collected here at Nebraska in the 2005 time frame, published in 2006, increasing distillers grain supplementation from 0.3% of body weight all the way up to 1.3% of body weight. This is some work that when I spent 6 years in Texas and had the opportunity to work with Dr. Jenkins, who's now so she published this data. This is actually on dormant native range, but also a low quality forage supplemented from 0 to 0.8% of body weight. And what I want to point out there is how parallel those 2 lines are. The response is remarkably similar. This is the most recent data that we've collected here at the ARDC near Meade, Nebraska. Dr. Mandy Jones is a graduate student who collected this data, 0.3, 0.7, and 1.1% of body weight supplementation, and saw a similar type response. I would point out that in Mandy's trial, we implanted the calves, and in these 2 studies, the calves weren't implanted. So that's probably the difference between where those lines are on the average daily gain. But again, the response, the slope of that line relative to the distillers grain supplementation is remarkably consistent across those 3 studies. We just feel like we can predict average daily gain based on the amount of distillers grains that you're going to supply quite well. Mandy also had the opportunity to look at the difference between grazing irrigated and dryland corn. Oftentimes we think of irrigated corn as being better. Obviously from a yield standpoint it probably is better. From a forage quality standpoint it is not. And so Mandy compared calves grazing irrigated and dryland corn. Of course this year was a drought year, and so any effects of the dryland are probably blown up a little bit more obvious this year. But still, if you think about corn residue as a forage, we talk about leaf to stem ratio and those types of things on range. That also holds up. Terry introduced the concept of different plant parts. The ratio of the stem to the rest of the plant has probably changed a little bit there, and so she, at a similar stocking rate, at 8 pounds of available forage per bushel of corn produced, she saw an increase of about 1/4 pound in average daily gain. Also, occasionally we get questions about the form of dry distillers grains. If you're familiar with the feedlot research, you may have heard the phrase wetter is better. Wet distillers grains has a greater energy value compared to dry matter, modified matter, and statistically she saw no difference in the gains due to the form of distillers grains. And so opens up opportunities for producers thinking about distillers grains type in terms of differences in gain, but what fits their system and what's most efficient and least expensive. So from a systems perspective, depending on marketing your calves, the level of supplement that we provide while they're grazing corn residue can carry over if calf goes to market. Gary Gillespie did a summary of 5 different studies over about a 10 to 15 year time frame where they fed 2 pounds of distillers grains versus 5 pounds of distillers grains. These didn't match up perfectly, but the winter average daily gain that she observed there was 0.55 pounds at 2 pounds of distillers grains supplement versus 1.41. When those cattle then went to summer grass as yearlings, there's a compensatory effect. So cattle which received more energy, more supplement during the winter phase, gained less. Okay, so that's a classic compensatory gain. Interestingly, though, since this is 3 phases, once you go into the feedlot, we've got a situation that I've called reverse compensation, where the cattle that received more energy during the summer gained less. And so providing more energy during the winter resulted in more feedlot average daily gain. And so at the end, you're marketing more total weight. Final body weight was greater at a greater level of supplementation. So if you're retaining ownership on those, if you're marketing those calves, you've got more gain here. If you're retaining ownership on those calves all the way through until they're marketed, you've got more saleable weight at the end based on a higher level of gain. I would add that we would not necessarily, any form of supplement that's achieving these different rates of gain, we would expect the same thing to hold true, not just for distillers grains. Terry then also looked at the profitability difference using her assumptions, lost about $10 per head, which is something we've been too familiar with. $10 probably wouldn't look too bad here the last couple of years. With the low level, and made $46 a head using her assumptions. The difference then being almost $56 a head between those 2 levels of supplementation. As corn prices increased then, we've also had to pay more for the distillers grains relative to corn. And so Carrie also looked at what happens if corn's at $5.50 versus $7.50, or if you're paying 85% the price of corn for distillers grains or 105% the price of corn. So each of these 4 scenarios represents $5.50 corn at 85% the price of corn for distillers grains, $5.50 corn, and you're paying 105% the price of corn for distillers, $7.50 corn at 85% the price of corn, and $7.50 corn at 105% the price of corn for distillers. As you would expect, as corn or distillers grains goes up, profitability goes down or gets worse, and that's the case regardless if you're feeding 2 pounds or 5 pounds of distillers grains. The point that I want to make is that if you take the difference between those 2 levels of supplement, it's greater in every case at the higher level of supplement. The difference is shrinking as prices go up, but still it was profitable to feed the 5 pounds of distillers grains. Carrie then asked the question, how expensive would corn have to get before the additional supplement no longer paid off? And the answer was $11.25 per bushel. So until corn gets over $10 and you're maintaining this calf, owning the calf through the entire production system, feeding a greater level, or about 5 pounds of distillers grains to achieve about 1.5 pounds gain during the winter appears to be profitable. Okay, I'm going to shift gears and just open the conversation and introduce the idea of subsequent crop yield. Concerns on the agronomic side that we need to be aware of and we need to have good answers for include what's going to happen to next year's crop, what happens to soil characteristics, organic matter, erosion, those types of things, and then what happens to water use. And so I'm going to open the conversation, and Aaron's going to follow up with that, and then Dr. Wortman's going to tell us how we're both wrong or right, depending on what he says. So I want to set the stage with some USDA data that was collected here at the ARDC at Meade, Nebraska. Brian Weinholt collected this data, and he looked at removing, stover removal is a percentage of what was available, so 0, about a third, and about 3/4% of the available stover that you removed, and diff or no tillage. So subsequent grain yield, and I believe a corn-on-corn system, 200 bushels to the acre. This is irrigated to 212. Statistically, these numbers are not different. So if you diffed, had the amount of stover that you removed had no effect on subsequent corn yield. Additionally, if you remove 40% or 80% of the stover, you also got about 200 to 210 bushels per acre. In a no-tillage system, this would probably be what would be preferred by our agronomic friends. So what is different? It's this number right here. If you removed no residue in a no-tillage system under irrigated conditions, you lost about 20 bushels to the acre in subsequent yield. So that's what I think is good data that I want to use to set the stage. Terry talked about different plant parts, and so we want to be clear that the animal is not consuming the entire plant. So what do they consume? Because the proportion of grain to forage remains about the same, as yields go up, the forage goes up. I tried to demonstrate that earlier, and so we think the appropriate stocking rate should be based on corn yield. So based on some data collected here, they'll eat about 2.6 pounds per bushel of husk, 8.5 pounds per bushel of leaf blade, and 4.2 pounds per bushel of leaf sheath, for a total of 15. We've kind of rounded that to 16, and then our recommendation is to take half of that. And so this is a good number to remember if you're looking at stocking for grazing purposes. 8 pounds of available forage on a dry matter basis per bushel of corn produced is a good number to keep in mind. So when we were comparing dry land and irrigated corn, of course those yields were different, but they were both stocked at 8 pounds of available forage per bushel of corn produced. So this is some data, grazing data, also collected here at ARDC. We've got about 20 years worth of data where calves following corn production grazed either in the fall or in the spring. Of course, compaction and mud in the spring is a problem, and so this is kind of the worst case scenario. They also double stocked, thinking that they would really hurt yield starting back in the early 90s. So we've got fall grazing here, strips of fall grazing, strips of spring grazing, and then ungrazed, and then repeated in 2 sections in a corn followed by soybean rotation here at the ARDC. These are pictures from those plots. So this would be non-grazed. So you can see a lot of available husk and leaf, and there's some cob there, and of course the stem is intermixed in there as well. This is a picture of the fall grazing. You'll notice an absence of husk and leaf. Still some cobs available there, and what's mostly left in the field at this point is the stem. And then this would be a picture of the spring graze, what we would be beyond our level of recommendation of grazing. Pretty much the only thing left there is cob and stem, and maybe a little bit more bare soil than what we saw in the previous picture. So assuming a 200 bushel to the acre corn yield at 8 pounds per bushel, that allows 1,600 pounds of leaf and husk, or 2.4 AUMs per acre. And that is 7680 would be the total residue at 80% of the amount of grain. And so we're removing 21% of that. 1,600 divided by 7680 is 21%. It's 45% indigestible, and so depending on how you value that redistribution of organic matter that is not retained in the animal, if you value that as organic matter back on the soil, we've only removed 11.6%, which is less, much less than what Weinholt removed. So based on those assumptions and remembering what Weinholt's data looked like, what would you expect to happen to yield when we graze? If you removed a third of it and yield went up, if we're removing 10 to 20%, what's going to happen to yield would you anticipate? So this is 20 years worth of data, again, in a corn-soybean rotation. This number is statistically bushel to the acre increase in soybean yield, with what Weinholz data would say. This is not statistically significant. This would be the following year's corn crop. It was numerically grazing increased yield. Statistically, we've not been able to pick up that difference. But the important thing from our perspective is that grazing does not decrease yield. And so we'll let Dr. Wortman pick it up from there. So winter supplementation of distillers grains or other type of supplement improves gain, carcass weight, and profit. So you want to have a strong supplementation strategy from a growing calf perspective. And then we feel like, if anything, in eastern Nebraska, irrigated corn, that there's a positive effect of removing some residue by grazing, not a negative effect. You've seen this website several times today, but lots of good information at beef.unl.edu. With that, I'd take any questions.